Frames of reference. Frames of reference. A system of coordinates required to locate the position of an object or an event in space is called a frame of reference. A system of coordinates required to locate the position of an object or an event in space is called a frame of reference. For example, to locate a point in space, we require three coordinates. We name them as x, y, z coordinates. If you know the coordinates of a point with respect to a coordinate system, we can locate that position. To locate a point in space-time, we require four coordinates. The fourth coordinate is time coordinate. So these coordinates are now known as x, y, z, t, space-time coordinate. So such a system of coordinates is known as frame of reference, or a coordinate system is known as frames of reference. We attach a coordinate system to an object like Earth, moving train, rocket, or sun, or to any star. Such a coordinate system attached to a body is known as a frame of reference. A coordinate system attached to a body is known as frame of reference. Types of frames of reference. Types of frames of reference. Frames of reference are categorized into two types: inertial frame and non-inertial frame. Inertial frame of reference and non-inertial frames of reference. These two are the two types of frames of reference. Inertial frame of reference. It is a frame of reference in which Newton's laws are valid, or Newton's first law of motion holds good. Earth is considered as an inertial frame of reference, though it is not actually, theoretically speaking, it is not actually an inertial frame of reference. Any reference frame is an inertial one if it is at rest or moves with uniform velocity with respect to an inertial frame. If it is at rest or moves with uniform velocity with respect to an inertial frame. So any rocket or object moving with uniform velocity with respect to Earth is an inertial frame. On Earth, the forces are due to the mass of the Earth. So whenever gravitational forces are present, such a frame of reference is known as inertial frame of reference. According to classical mechanics, only laws of mechanics are valid in inertial frame of reference. But according to Einstein's relativistic mechanics, all the physics laws are valid in inertial frames of reference. Non-inertial frame of reference. Non-inertial frames of reference. A frame of reference in which Newton's laws of motion does not hold good is known as non-inertial frame of reference. A frame of reference in which Newton's laws of motion does not hold good is known as non-inertial frame of reference. For example, accelerated and rotating frames of reference. An accelerated rocket or a rotating platform, they are non-inertial frames of reference. In non-inertial frames of reference, objects will experience a pseudo force. It is not real force like gravitational force. So in non-inertial frames of reference, the bodies will experience pseudo forces. A body placed in an accelerated lift, if a body is placed in a lift accelerated upwards with an acceleration, it experiences a downward force, which is a fictitious force or pseudo force. A coin placed on a rotating disc moves away from the axis of rotation due to fictitious force, which is nothing but centrifugal force. So, bodies situated in non-inertial frames of reference experience pseudo forces. Inertial mass and gravitational mass. Whenever a body is accelerated by applying a force, whenever a force is applied and the body is accelerated, by dividing the force with acceleration, we get the mass. Such a mass is known as inertial mass. So the ratio of force applied to the acceleration created by the force, this ratio is a mass that is known as inertial mass. The ratio between gravitational force and acceleration due to gravity is called gravitational mass. So every body experiences a gravitational force, and if W is the weight, that is gravitational force. So weight of the body divided by acceleration due to gravity gives the mass of the body. Such a mass is known as gravitational mass. Gravitational mass mg is equal to w by g. Inertial mass mi is equal to F by A. Inertial mass mi is equal to F by A. Gravitational mass mg is equal to w by g. A relation between inertial mass and gravitational mass. The formula for inertial mass is mi is equal to F by A, where F is force applied, A is acceleration produced. Gravitational mass mg is equal to w by g, where w is weight, g is acceleration due to gravity. Gravitational mass and inertial mass are found to be equal by experiment. By experiment, it is noticed that gravitational mass and inertial mass are equal. Gravitational mass is determined by a common balance. Gravitational mass is determined by a common balance. We know that mass is a measure of inertia of the body. We know that mass is a measure of the inertia of the body. The inertia or the mass depends on the matter contained in a body. It depends on the matter contained in a body. Inertial and non-inertial frames of reference with same result. Inertial or non-inertial frames with same result. Consider the time of free fall. The relation for time of free fall on earth is t is equal to square root of 2h by g. T is equal to square root of 2h by g. Or the vertical distance of free fall, x is equal to half gt square on earth. On earth, the free fall distance in time t is given by half gt square. Consider a rocket traveling with an acceleration a is equal to minus g. Consider a rocket traveling with an acceleration a is equal to minus g. In this rocket also, we notice that the time taken for free fall of a body is equal to square root of 2h by g. Or the free fall distance x will be equal to half gt square. We notice that the equations will be the same both on inertial as well as on non-inertial frame, which is accelerated at the acceleration due to gravity. Principle of equivalence. Principle of equivalence. If the experiments based on physical laws yield the same results, if the experiments based on physical laws yield the same results in an inertial frame and in a non-inertial frame, the two are said to be equal. An inertial frame and a non-inertial frame are said to be equal if the experiments yield the same results. Experiments yield the same results. This is known as the principle of equivalence. That means the non-inertial frame is equivalent to an inertial frame. Such a principle is known as principle of equivalence. Earth is one frame of reference and a rocket traveling with an acceleration a is equal to minus g is another frame of reference. These two frames of reference are equal, hence it is known as principle of equivalence. These two frames of reference are equal.